Good morning, students and parents. Welcome back to Mathematics 9 Valenzuela Live streaming class. Before we start our discussion, make sure your self-learning module is open on week 7 page. You must also have your pen and notebook with you. Are you ready? Let us begin. Our today's lesson is about operations on radical expressions, specifically addition, subtraction, and multiplication. At the end of this session, you should be able to perform operations on radical expressions, specifically in addition, subtraction, and multiplication. Last live session, you learned about simplifying radicals, and I knew you gained so much knowledge about it. But to check that, let us recall, when can radical expression be on its simplest form? If you could still remember, it could be on its simplest form when number 1, the radicand has no factors whose indicated roots can still be extracted. Number 2, the radicand does not contain a fraction. Number 3, the denominator does not contain a radical expression. Number 4, the index or order of the radical is in its lowest form. Let us check further your comprehension. In our first activity, you will simplify the radical expression that will be flashed on your screen. You will be given 10 seconds to answer. You can type your answer in the chat box. Are you ready? Let's begin. Number 1, square root of 125n. Timer starts now. Time is up. If your answer is 5 square root of 5n, you are correct. Number 2, fourth root of x raised to 4, y raised to 8. Timer starts now. The correct answer is xy squared. Number 3, cube root of 125x raised to 12, y raised to 6. 10 seconds to answer. Go! The correct answer is 5x raised to 4, y squared. Let's continue on number 4. Cube root of 40x raised to 8, y raised to 12. 10 seconds to answer. Go! The correct answer is 2x squared y raised to 4 cube root of 5x squared. For the last item, number 5. Square root of 2x cubed over square root of 25y raised to 4. 10 seconds to answer. Go! Time's up. The correct answer is x square root of 2x over 5y squared. If you got 5 correct answers, you are excellent, and you are now ready to learn our next lesson. Let us now proceed to the discussion about addition, subtraction, and multiplication of radical expressions. Can you still remember how we add or subtract algebraic expressions? That's correct. We add or subtract algebraic expression by simply combining similar terms. It has the same idea in addition and subtraction of radical expressions. We simply combined all like radicals. But what are like and unlike radicals? Like radicals are radical expressions with the same indices and radicals. Meanwhile, unlike radicals can be described as radical expressions with the same indices but different radicals. Radical expressions with different indices but same radicals. And radical expressions with both different indices and radicals. Did you get their difference? Let's see and try this next exercise. Activity number 2, you will group the following radical expressions as like and unlike radicals. You can either write your answers on your notebook and check them later, or simply type in your answer in the comment section. 10 seconds to answer. Ready? You may now start. Time's up. Let us group the following radical expressions. Where do you think cloud A belong? Like or unlike radicals? Very good. The correct answer is like radicals because both the radicals and the indices are the same. How about cloud B? Awesome! It is like radicals. Let's check cloud C. Perfect! The answer is unlike radicals because even if they have the same indices, they have different radicals. What about cloud D? Very good. The correct response should be unlike radicals. How about the radical expression in cloud E? Was it like or unlike radicals? Very good. It is like radicals. Lastly, let's check cloud F. Excellent. The correct answer is unlike radicals. Do you understand the like and unlike radicals? Fantastic! You are now ready to learn more. In addition and subtraction of radicals, we just simplify all the given radical expressions, if possible. Then, add or subtract the coefficients and affix the like radicals. Let's try example number 1. Negative 10 cube root of 7 plus 12 cube root of 7. The two radicals are like radicals. As you look at the radicands, they are in their simplest forms. Thus, we simply add the coefficients, negative 10 and 12, and it becomes quantity negative 10 plus 12 cube root of 7. By simplifying, it will be 2 cube root of 7. Example number 2. 2 square root of 50 plus square root of 18. We need to simplify both radicals. Thus, we will get the factor of each radicand according to the index. Given that the index is 2, we therefore obtained a radicand factor which is a perfect square. We have now 2 square root of 25 times 2 plus square root of 9 times 2. By simplifying square root of 25, we have 2 times 5 square root of 2. By simplifying square root of 9, we have 3 square root of 2. 2 times 5, we have 10 square root of 2 plus 3 square root of 2. They are like radicals. So, we combine the coefficient and becomes 13 square root of 2. Example number 3. B squared square root of a cube b minus square root of a cube b raised to 5 minus ab square root of ab cube. Factor out the radicands. We have b squared square root of a squared times a times b for b squared square root of a cube b. Square root of a squared times a times b raised to 4 times b for square root of a cube b raised to 5. ab square root of a times b squared times b for ab square root of ab cube. Extract the roots of the perfect square factor and multiply to the coefficient outside the radical sign. The non-perfect square will remain inside the radical sign. We have now b squared times a square root of ab minus a times b squared square root of ab minus ab times b square root of ab. By simplifying, we have ab squared square root of ab minus ab squared square root of ab minus ab squared square root of ab. What do you observe? Very good. They are like radicals. As a result, we will combine the coefficients and then copy the radicals. We have negative ab squared square root of ab. Example number 4. 3 square root of 12ab squared plus 3b square root of 75a minus 3 square root of 27ab. Factor out the radicands and we have 3 square root of 4 b squared times 3a for 3 square root of 12ab squared. 3b square root of 25 times 3a for 3b square root of 75a. And negative 3 square root of 9 times 3ab for negative 3 square root of 27ab. Extract the roots of the perfect square factor and multiply to the coefficient outside the radical sign. And the non-perfect square will remain inside the radical sign. We have 3 times 2b square root of 3a plus 3b times 5 square root of 3a minus 3 times 3 square root of 3ab. By simplifying, we have 6b square root of 3a plus 15b square root of 3a minus 9 square root of 3ab. What do you notice to the radical expressions? Very good. Only 2 radicals are like radicals. So, we will combine both radicals and copy the remaining radical. We have 21b square root of 3a minus 9 square root of 3ab. After we add and subtract radicals, the next operation to discuss is multiplying radicals. There are 3 cases on how we multiply radical expressions. Number 1, in multiplying radical expressions with the same indices, use the property and root of a times and root of b is equal to and root of ab. Number 2, in multiplying binomials involving radicals, you may use the distributive property, FOIL method, or special products like square of binomials and difference of 2 squares. Number 3, in multiplying radicals with different indices, use the property and root of a and root of b is equal to m root of a raised to m, b raised to n. Example for case number 1. Square root of 15 n squared times square root of 10 n cubed. They have the same indices, so we simply multiply the 2 radicals. Square root of 15 n squared times square root of 10 n cubed is equal to square root of 150 n raised to 5. Factor out 150 n raised to 5, we have square root of 25 times 6 times n raised to 4 times n. Extract the roots of the perfect square factors, which are 25 and n raised to 4. We have 5n squared. And the non-perfect square will remain inside the radical signs. And we have square root of 6n. Therefore, square root of 15n squared times square root of 10n cubed is equal to 5n squared square root of 6n. Example number 2. 4x cube root of 9y raised to 4 times 2 cube root of 9x squared. Multiply first the coefficients. So 4x times 2 is equal to 8x. Then multiply the two radicals. Cube root of 9y raised to 4 times cube root of 9x squared is equal to cube root of 81x squared y raised to 4. Factor out 81x squared y raised to 4. Remember, we factor the radicand according to the index. Since the index is 3, the radicand factors should have perfect cube. And we have 8x cube root of 27 times 3 times x squared times y cubed times y. Extract the roots of the perfect cube factors, which are 27 and y cubed, and multiply to the coefficient outside the radical sign. And we have 8x times 3 times y. The non-perfect cube will remain inside the radical sign, which is 3 times x squared times y. Simplify the expression, and we have 24xy cube root of 3x squared y. Therefore, the product of 4x cube root of 9y raised to 4 times 2 cube root of 9x squared is equal to 24xy cube root of 3x squared y. Next example for case number 2. 2 square root of 5 times the quantity of square root of 6 plus 2. In this, we will use distributive property. We multiply 2 square root of 5 to square root of 6 and 2 square root of 5 to 2. And we have 2 square root of 30 plus 4 square root of 5. Since both 30 and 5 do not have a perfect square factor, therefore, it will be the final answer. Next example. Quantity negative 3 square root of 3k plus 4 times the quantity of square root of 3k minus 5. As you can see, the given radicals are both binomial. So we will use the FOIL method to solve this problem. Negative 3 square root of 3k times square root of 3k is equal to negative 3 square root of 9k squared. Next, negative 3 square root of 3k times negative 5 is equal to 15 square root of 3k, followed by 4 times square root of 3k is equal to 4 square root of 3k. And lastly, 4 times negative 5 is equal to negative 20. We have now negative 3 square root of 9k squared plus 15 square root of 3k plus 4 square root of 3k minus 20. Simplify square root of 9k squared is equal to negative 3 times 3k. As you can see, 15 square root of 3k plus 4 square root of 3k are like radicals. So we will combine the two radicals and we have 19 square root of 3k. Simply copy negative 20. Simplify the radical expression and we have negative 9k plus 19 square root of 3k minus 20. Next example. Quantity square root of 5x plus square root of 3y times the quantity of square root of 5x minus square root of 3y. Observe the given example. What have you noticed? Very good. The radical terms inside the parentheses are the same except for their operations. In this case, we can use the idea of special products, specifically the difference of two squares. Let a is equal to square root of 5x and let b is equal to square root of 3y. By substitution, we have quantity square root of 5x squared minus quantity square root of 3y squared. Simplifying square root of 5x times square root of 5x, we have square root of 25x squared. Square root of 3y times square root of 3y, we have square root of 9y squared. Simplifying square root of 25x squared, we have 5x. And square root of 9y squared, we have 3y. Therefore, quantity square root of 5x plus square root of 3y times quantity square root of 5x minus square root of 3y is equal to 5x minus 3y. Next example. Quantity square root of 2x plus square root of 3y squared. In the given example, we can apply the idea of square of a binomial. Let a is equal to square root of 2x and b is equal to square root of 3y. By substitution, we have quantity square root of 2x squared plus 2 times square root of 2x times square root of 3y plus the quantity of square root of 3y squared. By simplifying each term, we have square root of quantity square root of 2x squared is equal to square root of 4x squared. 2 times square root of 2x times square root of 3y is equal to 2 square root of 6xy. Quantity square root of 3y squared is equal to square root of 9y squared. Simplifying square root of 4x squared, we have 2x. Copy 2 square root of 6y. And square root of 9y squared, we have 3y. We have now 2x plus 2 square root of 6xy plus 3y. Are there any similar terms? Very good. There are no similar terms. Therefore, 2x plus 2 square root of 6xy plus 3y will be our final answer. Next example. Quantity square root of 4x minus square root of 2y squared. Again, it is an example of a square of binomial. But this time, the operation between the two radicals is subtraction. Let A is equal to square root of 4x and B is equal to square root of 2y. By substitution, we have quantity square root of 4x squared minus 2 times square root of 4x times square root of 2y plus quantity square root of 2y squared. By simplifying each term, we have quantity square root of 4x squared is equal to square root of 16x squared. Negative 2 times square root of 4x times square root of 2y is equal to negative 2 square root of 8xy. And quantity square root of 2y squared is equal to square root of 4y squared. So we have now square root of 16x squared minus 2 square root of 8xy plus square root of 4y squared. Simplifying, we have now square root of 16x squared is equal to 4x. Negative 2 square root of 8xy, we have negative 2 square root of 4 times 2xy, which is equal to negative 2 times 2 square root of 2xy, equals to negative 4 square root of 2xy. So therefore, simplifying negative 2 square root of 8xy is negative 4 square root of 2xy. And square root of 4y squared, we have 2y. Are there any similar terms? Very good. There are no similar terms. Therefore, 4x minus 4 square root of 2xy plus 2y will be our final answer. Last case, in multiplication of radicals. Example, square root of a times 4th root of a cubed. To solve this problem, we use the property and root of a times m root of b is equal to m root of a raised to m b raised to n. Let n is equal to 2 and m is equal to 4. By substitution, we have 2 times 4 root of a raised to 4, a cubed raised to 2. Simply, we have 8 root of a raised to 4 times a raised to 6. which is equal to 8 root of a raised to 10. Simplifying 8 root of a raised to 10, we have 8 root of a raised to 8 times a raised to 2, which is equal to 8 root of a squared. But the index or order is not in simplest form. In order to do this, get the common factor of 8 and 2, which is the common factor is 2, and divide to the index and exponent in the expression. So we have a fourth root of a. For our last example, square root of x y cubed times cube root of x squared y. Again, we will use the property nth root of a times mth root of b is equal to nm root of a raised to m b raised to n. Let n is equal to 2 and m is equal to 3. By substitution, we have 2 times 3 root of quantity x, y cubed raised to 3 times the quantity of x squared raised to 2. Simplifying, we have 6 root of the quantity x cubed y raised to 9 times the quantity of x raised to 4 y squared. Then, 6 root of x raised to 7 y raised to 11. Factor out the radicand, we have 6 root of x raised to 6 times x times y raised to 6 times y raised to 5. Simplify, we have now x, y, 6 root of x, y raised to 5. Therefore, square root of x, y cubed times cube root of x squared y is equal to x, y, 6 root of x, y raised to 5. I hope you learned something from our discussion. To sum up our lesson today, we learned that by adding and subtracting radical expression, we have simply combined all like radicals. To add or subtract radical expressions, we simplify the given radical expressions if possible and add or subtract the coefficients, then affix the like radicals. In multiplying radical expressions with the same indices, use the property nth root of a times nth root of b is equal to nth root of ab. In multiplying binomials involving radicals, you may use the distributive property, FOIL method, or special products like square of binomials and difference of two squares. In multiplying radicals with different indices, use the property nth root of a times nth root of b is equal to nm root of a raised to m b raised to n. You can now ask questions. A question was raised from one of our viewers. Ma'am, how are radicals used in everyday life? Nice question. Actually, radical expressions are utilized in financial industries to calculate formulas for depreciation, home inflation, and interest. Electrical engineers also use radical expressions for measurements and calculations. Biologists compare animal surface areas with radical exponents for size comparisons in scientific research. Those are examples of uses of radical expressions. Another question, is there another way how to multiply radicals with different indices? Yes, there is. Another way of multiplying radicals with different indices, first, rewrite the radicals as exponential expressions. Change the exponents so they have a common denominator. By doing this, the bases now have the same roots and their terms can be multiplied together. If I was not be able to answer some of your queries, you can ask your math teachers during your follow-up discussions. For your assignment, answer keep trying numbers 1 to 10 and assessment numbers 1 to 7 on your self-learning module, pages 26 to 27. Thank you for listening. Keep safe, everyone, and see you in our next session.